Series on sprinting biomechanics is a 2004 paper by Stefanyshyn and Fusco titled Increased Shoe Bending Stiffness Increases Sprint Performance. Another great example of a title that gives you the key finding right there in the title. This one was a pretty straightforward design. Here they were examining if increasing the bending stiffness of the shoe via a carbon fiber plate affects sprint performance in terms of the time it takes to complete a sprint. Pretty straightforward design here. They had 34 athletes participating in the study, and these were pretty high-level athletes. That was some individuals from the University of Calgary track and field team, some more individuals from the University of Tennessee track and field team, and then some members of the Cuban national team for track and field. So some pretty fast, high-level athletes that were tested here. And so the individuals ran in 4 different shoe conditions, which was actually really just one shoe. So they were always wearing the same shoe, just a typical track and field spike that you see here in figure 1. And then they increased the bending stiffness of the shoe, so the bending stiffness around the toe joint, the metatarsophalangeal joint there, by inserting either a flimsy insert here that did nothing, just to always have something inserted there as kind of a control, or one of these 3 carbon fiber plate inserts, which were progressively stiffer inserts. So a normal condition with no carbon fiber, and then 3 conditions with progressively stiffer carbon fiber plates in here. So this was a little bit different from like the marathon running shoes we looked at that had the carbon fiber plate built into the midsole. This was just a regular sprinting spike. It didn't have the carbon fiber plate built into it, and then they inserted the carbon fiber inserts into the top of the shoe, just like you would insert your foot into a shoe. So it's kind of like insoles. If anyone in the class wears insoles, you typically insert like something kind of squishy and soft into the shoe if you have like foot pain or foot problems. Pretty common thing that a podiatrist might prescribe for you if you have foot issues. But here they were doing a similar thing, not with squishy insoles, but with carbon fiber insoles to stiffen up the midsole region of the shoe in terms of its bending stiffness. The athletes then did 40-meter sprints in each of these shoe conditions, and they timed them over the final 20 meters of the sprint. So starting here from a standing start, so standing upright at the starting line, and then accelerating over the first 20 meters, and then they were timed for 20 to 40 meters. The reason that they only timed them for the final 20 meters of this 40-meter sprint, I think, is probably because you're starting from rest here, a standing start, and then you speed up to your top speed. And the idea behind these shoe conditions and increasing the bending stiffness of the shoe is to ideally increase the top speed that you can reach and sustain during the sprint. I don't think there's a strong, at least as strong, theoretical argument for it helping too much with acceleration, which is what's going on for certainly for most of the first 20 meters there. Most people, even especially fast people that have a lot of speed to build up, can't get to their top speed in under 20 meters or so. And I would say even like 30 to 40 meters for some people may not be enough to truly get up to your top speed. But they were skipping the first 20 meters here in terms of the time because they wanted to measure their performance here at or near their top speed over the last 20 meters here. Just as kind of an aside, you notice that they did this from a standing start. So that would be like if you were standing upright at the starting line, and then you'll typically like take a step back and then bolt and start your sprint. Normally for sprinting in like track and field, you would start out of blocks, right? If you're not familiar with what these techniques are, let me pull up a video here and show you what I'm getting at exactly. Hopefully you guys can see this. So a standing start would just be like, imagine my trash can here is the start line, and I would start on the line, and then I would typically like take a step back and then start my sprint. If I was starting out of blocks, that's what you see in like the Olympics in like shorter track and field races, like 100 meter, 200 meter, 400. I don't think they use them in the 800. I think it's just in the 100 through the 400 or the 60 meter if you're watching indoor track. That's where the athletes are like down like this in like a crouch, and they have their feet planted on these apparatuses on the ground, which are these kind of triangle-shaped blocks that they would then push off out of the start there to get up to start the race and to get up to their speed. So you might think, since those blocks are used at like track and field races on tracks, which are for speed, and typically where you want to be running the fastest, that maybe it's fastest to start out of blocks like that, and slower to do the standing start. It kind of depends from person to person, but generally most people are faster using the standing start. The starting out of blocks requires a good deal of strength and power, and in particular, a very specific and refined technique to do it well. And so most people are actually faster when you do a standing start. The reason that using blocks is mandatory in like international track and field competitions is not related to speed. It's related to fairness. The blocks, it's easier to ensure that everyone is truly starting from rest, which is very difficult to do when everybody's just kind of standing at the start line, and then you're not supposed to move until you hear the gun. But it's very difficult to determine that when everybody's just kind of standing there and is told, okay, not move, don't move. With the blocks, and especially modern blocks, which you can instrument with little sensors that can tell, like, okay, when they start pushing on it and and things like that, it's much easier to ensure that everybody is starting truly from rest before the gun goes. So the blocks are actually for controlling when people start and when they start moving for the sprint. It's not for speed. So here, because they were interested in speed, they just did a standing start. Okay, what did they find? If you look here in figure 2, you might think that they didn't find much. Okay, there's a little star here, which means this was a significant difference. So running in the least stiff carbon fiber plate, which had a stiffness here of 42 newtons per millimeter, so the least stiff of the 3 plates that they used. On average, at least by their statistical metrics that they used, led to faster sprint times or shorter times to complete that final 20 meters of the sprints than running in their normal standard shoe with no carbon fiber plate in it. But if you look at the y-axis here, it was a pretty small difference. So I'm kind of estimating here, but it looks like the average time in the standard shoe was about 2.17 seconds, and the average time in the 42 newtons per millimeter stiffness shoe was about 2.15 seconds. So improving the time there by about 2/100ths of a second. That may not seem like much, but in sprints, especially really short sprints like this, that's kind of a big difference. So that's bordering on what's a substantial difference. In a 100-meter dash, hundredths of seconds matter. Like there's been plenty of times in the history of the world record for the 100-meter dash where somebody has set a new record by beating the previous record by 100th of a second or 200ths of a second. It's not always like Usain Bolt where he's blowing away the record by tenths of a second at a time. So fractions here of seconds, hundredths of seconds are meaningful, especially for a really short sprint like this. This is 1/5 of the length of the 100-meter dash here. So 1/100th of a second, 200th of a second, 300ths of a second. These are actually meaningful improvements in performance for a distance like this. Where things get a little bit more impressive in terms of the plate is this is comparing how everybody did in that specific plate. And one thing that they highlight here, and you can sort of see this in this comparison for individual results for 2 subjects, is that different individuals ran faster or ran their fastest time in different plates. Everybody wasn't the best in the least stiff plate here. Some people were the best in the moderate stiffness plate, some were the best in the high stiffness plate. For example, subject A that they are showing here, they were the fastest in the medium stiffness plate. They were about, looks like 5/100ths of a second faster in the medium stiffness plate compared to the standard shoe with no plate. So 5/100ths of a second is quite a bit of time over 20 meters. That's a very meaningful improvement in performance. Compared here to another subject who ran their fastest time on average in the least stiff shoe and was about, looks like a little bit more than 3/100ths of a second faster in that shoe compared to their standard time. So 2 different individuals, both faster with a carbon fiber plate in their shoe versus their standard shoe, but running their faster times in different carbon fiber plated shoes. Subject A here being quite a bit faster in the medium stiffness shoe than with any other plate, and subject B here running a little faster in every plate, but just a little bit faster than the other 2 plates here in the lowest stiffness plate. What they then did to kind of demonstrate the general effect of the plate is down here in figure 5. And this is where if you compare everybody running in the standard shoe with no plate to everybody running in whatever plate was the one that gave them the fastest time. And there you see on average a little bit more impressive result for the plate. There on average everybody ran 0.03 of a second faster in the carbon fiber plated shoe, whichever of the plates it might have been, versus the standard shoe, which is again a meaningful result. 0.03 of a second over 20 meters, or over the final 20 meters of a 40-meter dash is a pretty substantial improvement in time. You can also kind of glean how impactful and important the plate was by looking here at the individual level results. This is showing data for each of the 34 subjects, the percent improvement in terms of improving their sprinting time in whatever plate was the one that was fastest for them. If the bar is positive here, that means they were faster in one particular plate compared to their standard shoe. And if it's below the line, they were slower in all of the plates compared to their standard shoe. So you can see here that for only 3 out of the 34 subjects, and let's call it 4 here because it looks like there's, or 5 actually, let's call it 5 here because it looks like there's 5 subjects who either slowed down with the plates, so these 3 here with the negative lines, or did not improve at all in any of the plates, which are these 2 here. Looks like subject 13 and subject 28 who ran same times in all the plates that they did in their regular shoes. But for everyone else, so that would be the other 29 subjects, they all ran at least a little bit faster on average in at least one of the shoes with a carbon fiber insert inside of it. And if you count here everybody that's near or above this 1% line, 21 out of the 34 subjects improved their sprinting speed over those 20 meters by at least 1%, and sometimes up to 3.5%, 3 to 3.5% in some participants with a carbon fiber insert in the plate. They then get into, okay, there were some subject-specific differences here. Adding a plate in general was beneficial for sprinting time, but the results varied quite a bit. And a particular plate wasn't best for everyone. Some people were best in a relatively low stiffness plate, some required a stiffer plate, and some a much stiffer plate in order to see a meaningful improvement in their sprint time. Here they speculate that the mechanism on this is similar to the concept that we covered with the Vaporfly shoes and with the carbon fiber plate in the Vaporfly shoes and the midsole cushioning in the Vaporfly shoes, in that it's minimizing energy losses, in that you're putting energy into the shoe with each step, and the shoe is inevitably losing a good chunk of that energy. So the shoe is taking mechanical energy away from your body with every step that you take. And so maybe improving performance, we can get a good insight on this by trying to design shoes that minimize the amount of energy that's lost, or that returns the largest fraction of the energy that you put into it with your muscles. And so they speculate here that that's what the carbon fiber plate was helping you do. However, they also say that that doesn't explain everything here. That in particular, that doesn't explain the variance between subjects on widely different stiffnesses being optimal for particular individuals. What is it that's making a certain plate best for a certain individual? There they speculate that it's related to individual subject-specific muscular properties, like the particular shape of an individual's force length or force velocity curve. Or, like we covered a couple lectures ago, if I can find the reading number 9 for sprinting here. Give me 1 second here. Or sorry, reading number 7 for sprinting, where we covered the different shapes of the force-velocity relationships. So if you have somebody that has certain fractions of fast twitch fibers in certain muscles, or certain strengths on the eccentric limb for certain muscles, but different for other muscles and different from other muscles, or even those same muscles in different individuals. So you can imagine different shapes of these curves here in terms of the concentric limb here and the eccentric limb here. Those shapes of these force velocity curves vary a lot from muscle to muscle and from person to person. And so you might imagine that the characteristics of performance of your muscles, which we saw were affected by these shapes of these force velocity curves, might have an influence on what bending stiffness of a plate in your shoe, or just more broadly, the characteristics of equipment that you use in sports, the properties of your muscles very much interact with the properties of the equipment that you're using in order to affect performance. And so it's likely an individual level thing related to your individual muscular performance characteristics, such as the shape of your force velocity curve, that determines what bending stiffness would be optimal for you for something like sprinting or running economy or jumping height or whatever element of performance we might be looking at. They did attempt here to see if the optimal stiffness of the shoe, in terms of what shoe's stiffness was, or what carbon fiber plate stiffness was best for sprinting performance, was easily explainable by like simple measurements you could take from somebody. Like did the best stiffness correlate with body mass or with height or with shoe size? And really they didn't, or even sprinting time in terms of did faster people need a stiffer plate or a less stiff plate. None of those three, I'd say, simple measurements correlated well with the stiffness. There really, or the optimal stiffness of the shoe for individuals. There really wasn't any relationship there between simple things like how heavy you are, how tall you are, what size shoe you wear, how fast you are. Those things didn't seem to explain what the optimal bending stiffness was, suggesting it's some more detailed biomechanical characteristics, such as the mechanical properties of the muscles, that's affecting which bending stiffness is the best. So, take-home message for this one, inserting a carbon fiber plate into your shoes seems like it can improve sprinting performance. I guess that seems to be kind of a theme in the class here. I wasn't intending for it to be a theme, but we've seen that carbon fiber plates in the shoes seem to be beneficial for performance and endurance running, beneficial potentially for jumping, beneficial potentially for sprinting. So I guess if you want to improve general athletic ability, maybe think about using a shoe with a stiff midsole or with a carbon fiber plate in the midsole. Why exactly that affects performance is a little bit up in the air right now. It's probably related to minimizing energy losses, but that doesn't explain everything. And then related to that, which particular carbon fiber plate, or what characteristics of the plate, how big should it be, how stiff should it be to optimize performance on an individual level, we really don't know. A lot of progress still to be made there in terms of straightforward, accessible ways for determining, okay, what's the best carbon fiber plate for this athlete in specific. So generally, if you want to improve sprinting performance and want a quick fix for that, putting a carbon fiber plate in the shoe might be helpful. But if you want to maximize sprinting performance, you may need to test several plates there, and may have quite a bit of work from you in terms of determining, okay, what plate is best for this individual. We're not quite there yet in terms of being able to easily and quickly determine that.